Watch what happens when I hit enter. A prompt leaves my local terminal, queries a live AI agent running on AWS, and instantly streams back a response. No manual server configuration required. In this tutorial, we are going to build, test, and deploy that exact agent. We will use the AgentCore CLI to handle the entire lifecycle, keeping us out of the AWS console and focused on the code. Before we write any commands, we need to prep our local environment. You will need Node.js version 20, Python 3.10, and the AWS Cloud Development Kit, or CDK, installed on your machine. On the cloud side, make sure your local AWS credentials are fully configured. You also need to open the Amazon Bedrock console and explicitly request model access for Anthropic Claude Sonnet 4.0. Taking a moment to verify these versions and model permissions right now eliminates the root causes of almost all deployment errors later on. With the environment set, we can start building. Step 1 is installing the CLI tool itself. Open your terminal and run npm install-g at aws/agentcore to install the package globally. Next, we create our project scaffolding. Type AgentCore create, give your project a name, and add the --defaults flag. This automatically configures a Python-based agent using the Strands framework and Bedrock as the model provider. Keep in mind, your project name must start with a letter, contain only alphanumeric characters, and stay under 36 characters long. Looking at this generated directory tree, you will see two vital pieces. The agentcore.json file holds your project's configuration, which dictates how the cloud resources will be built. Below that, inside the app folder, is main.py, your actual executable code. Inside that Python file, the CLI has already written the starter code. It imports the Strands framework, initializes the Bedrock model connection, and sets up the basic request handler for incoming prompts. Let's test that logic safely on our own machine. cd into your new project directory and run AgentCore dev. This creates a Python virtual environment, installs the dependencies, and starts a local development server. By default, this server runs on port 8080. If another application is already using that port, the server will fail to start. You can fix this by adding -p to the command and specifying an alternate port number. Leave that server running. Open a second, separate terminal window so we can act as the client and send a test message. In the new window, type AgentCore dev followed by a simple prompt in quotes, like, "Hello, tell me a joke." Receiving a valid response here means your core Python logic works exactly as intended. We have verified the code in isolation, meaning we can move forward to AWS deployment with confidence. Now we push our local work to the cloud. Return to your primary terminal and run AgentCore deploy. Methodical. This command initiates a three-phase sequence. First, the CLI reads your configuration and compresses your agent code into a standardized code zip archive. Second, the AWS CDK takes over. It uses that code to synthesize a precise blueprint, a CloudFormation template tailored to your specific deployment needs. Finally, AWS provisions the actual infrastructure. It creates the necessary identity and access management roles and spins up the Amazon Bedrock AgentCore runtime to host your newly zipped application. You can watch this entire process unfold by appending the -v flag to your deploy command, which outputs real-time, resource-level events directly to your screen. If the process stalls or fails here, double-check your initial prerequisites. An AWS account that has not been bootstrapped for the CDK or profile missing CloudFormation permissions will block the deployment entirely. Once the deployment completes, we can talk to the live agent. Run AgentCore invoke, pass a text prompt in quotes, and add the -stream flag. As the text streams onto your screen in real time, you are actively communicating with the Bedrock AgentCore runtime hosting your application in the cloud. If you want to ask follow-up questions, add the -session ID flag with a custom identifier. This forces the agent to maintain your conversational context across multiple separate terminal commands. Alternatively, if you run AgentCore invoke without any prompt string at all, the CLI launches a persistent, interactive terminal UI that handles the streaming and session memory automatically. By executing a single deploy command, we successfully bypassed hours of manual AWS configuration, taking our code from a local folder to a fully operational live cloud endpoint. Before we wrap up, verify everything we just built by logging into the AWS console and searching for your project name under CloudFormation stacks. To avoid paying for resources you aren't using, we need to tear this environment down. Step 1 is running AgentCore Remove All, which strips the target resources out of your local agentcore.json file. Step 2 is running AgentCore Deploy one last time. The CLI detects the newly emptied local configuration, syncs that state with AWS, and safely deletes the corresponding cloud resources. As you build more advanced applications, you can use AgentCore Add to attach conversational memory stores, or swap the default build type for a Docker container to manage custom dependencies. Controlling your infrastructure as code means you can scaffold, test, deploy, and destroy AI agents rapidly and predictably. You now have a complete, cost-effective workflow for iterating on enterprise-ready AI.